Hello guys, my name is Sai. Okay, have you ever wondered how some of the most advanced machine learning models are able to make predictions with such accuracy on these present generations? One key reason is transfer learning. So today my presentation is transfer learning, leveraging pre-trained knowledge to build better models. Okay, transfer learning is an effective technique for enhancing the performance of machine learning models, particularly when there are limited data available for the new task. So I'm going to dwell a little bit more about the topic. It is a powerful technique that allows us to reuse knowledge gained from previous tasks, even if they are different in nature. So this not only saves time and resources, but often leads to better performance on the new task. In today's world where data is becoming increasingly complex and costly to acquire, transfer learning has become a critical tool for machine learning practitioners. So what are the main key differences between transfer learning and the traditional machine learning techniques? So transfer learning uses a pre-trained model to leverage knowledge from the previous task, whereas in the traditional machine learning techniques, we start from the scratch. And in transfer learning, it only uses less time to process the data, and the training times are a little bit faster than traditional machine learning techniques. And in transfer learning, we generalize better to new and unseen data, whereas in traditional machine learning techniques, we can struggle to generalize new and unseen data. Overall, I can say that transfer learning is an efficient, effective, and accessible to a wide range of users. And there are different types of transfer learning techniques. They are fine tuning, feature action, domain adaptation, multitask learning, zero shot learning, inductive transfer learning, and so on. I'm going to explain a little bit about those. So, multitask learning. Multitask learning is training a single model to perform multiple tasks and share knowledge between them. And in zero shot learning, we transfer knowledge between tasks with different output spaces by learning and mapping between them. And in fine tuning and feature extraction, they basically improve the performance of a new task by optimizing pre trained models weight with labeled data. And for every topic, there will be pros and cons. So I'm going to go. The benefits of transfer learning are improved performance, lower data requirements, reduced resource requirements, and generalization. And there are certain limitations as well for the transfer learning model. So there are domain specificity. So in transfer learning, we generally use a pre-trained model. So we have to take only specific data set and tasks. So it may in for the new model it may not be very helpful, and it may lead to overfitting, and the similarity of tasks can be very dissimilar, so the benefits of transfer learning may be limited, and sometimes it may lead to bias between pre-trained models, as when they are transferred to new tasks, it can lead to unintended consequences and negatively impact the performance, and it may also result in lack of transparency. And there are certain applications of transfer learning as well where we can utilize in different areas, and such are image recognition, where we use image recognition tasks. For example, a pre-trained model for object recognition on ImageNet can be fine-tuned. Such a situation, we can see cats and we or dogs we can identify very easily, but whereas in computers, there are certain images that are stored, and it is hard to identify species of animals. So image recognition is one such useful tool, and natural language processing as well. It is usually extensively used nowadays. For instance, a pre-trained model like BERT can be fine-tuned for different NLP tasks like sentiment analysis, named entity recognition, question answering. And the other utility we can do is speech recognition. It can use to improve speech recognition accuracy in scenarios with limited data. For instance, a pre-trained model on a large recognition dataset can be fine-tuned on a smaller dataset, which can be used in medical dictation or financial transcription. And how is it the procedure of transfer learning performed? First, we choose a pre-trained model based on the target task and data type. Then we freeze the initial layers of the pre-trained model to use them as feature extractors and prevent overfitting. And then we replace the outer layer of the pre-trained model with a new layer for the target task. And then we train the new model on the target task dataset with randomly initialized new layer weights and update only some of the subsequent layers. And then we fine tune the model with a small learning rate if necessary. And at last, we evaluate the new model's performance on a separate test dataset and make any necessary adjustments. And these are some of the references where I have taken information as well as images. Thank you.